Okay, so here we are in our next video. Um, we, in our last video, got things set up so that these two labels will update based on sensing and acceleration. The next thing we want to do is we want to be able to keep track of the position of the ball. Now, we haven't yet built anything to make the ball move, so these numbers aren't going to change yet. But that's going to come in the next video. That's coming soon. Before we can make the ball move, we need to know where the ball is to start with. So that's the next thing is we're going to update these two. So let's do a save as. Let's call this version 2. And we want those two labels to update now. So let's think about this for a second. In our block view, this is the structure that we use to update the acceleration labels. We're going to want something very similar to update the position labels, but notice there's a problem. Inside of this structure, there are some locally defined variables for acceleration, but there's nothing about position. So if I'm going to keep track of position, I need to invent some new variables to keep track of position. We also want those variables to keep track of position whether or not the tablet is moving, right? If we go back to this, imagine this is my actual tablet. It's not moving at all. The accelerations would be 0, but the ball has a position, and its position is not 0. So we want these position values to be independent of acceleration. In other words, we want to be able to access those values inside of this, but we don't want that to be depending on this. We want it to be outside of that structure because the ball doesn't depend on acceleration. Bottom line is this. It cannot be a local variable that we use because we want it to exist outside of the accelerometer. So what I need to do is go to my variables tool drawer and I need to initialize a global variable. The global variable is outside, it's independent, but we can call it from inside and still use it. And we're going to call one of them the X position. And we're going to need another one for the Y position. Okay. So this is creating two global variables, one called X and one called Y position. But we also need to set them to some value. So remember, when our program first starts, the ball has a position. My ball starts at 100, 100. So I'm going to have these variables initialized to that value. So in the math, there's a spot where I can find numbers. And I'm going to have the X position initialize to the value 100. And then I'm going to do the exact same thing for the Y. So now we've got variables that keep track of the Y position. The next thing I need to do is to update the label to reflect the value of the position. Now again, right now the ball doesn't move. We haven't built that functionality yet. But in the next video, as soon as it senses an acceleration, we're going to make the ball move. So that means every time it senses acceleration, the ball is going to move. That means every time it senses an acceleration, these labels need to update. So back into our block view, we're going to do something similar. We're going to set the label to be equal to the position, and we want that to happen every time it feels acceleration. So where's our labels? Here is the X position label over here, and we want to set its text to be equal to its X position. And we want to do that every time it senses motion. And then we want to do the same thing for Y. When the Y position, when it senses motion, let's update that label to show the actual position. Okay. Now, what this will do is it will make these 4 labels change every single time, I should say update, every single time we move the tablet. But as of right now, the ball doesn't actually move. And so even though these are updating, the number won't ever change because the ball is not moving yet. In the next video, we'll make the ball move. And as soon as the ball moves, then these numbers should automatically change to match, right? So you can go ahead and save your work from there, and we'll move on in the next video here in just a second.